section 514 is called face plate starter. We're going to walk through this process of starting this DC shunt motor connected to something called a face plate starter. It's really just a variable resistor that as the motor comes up to speed, we lower the resistance. And what we're trying to prevent is that initial surge of current that occurs. Now, one thing I want you to think about as we go through this, and we're going to walk it through, and you know, as we're talking about it, you know, we're describing this thing, and you know, we're thinking about manually doing all of this stuff, and you know, that everything is manually monitored and so forth. But I want you to know that these types of mechanisms are used in, you know, sophisticated electronic controls of motor systems, be it in a particular device, or it could be part of a bigger system, a PLC control, or a drive control that can do all of these things that we're thinking about as happening manually. But at the same time, you know, I love the way that this book goes through and explains these things the way that he does. So when you do actually connect these things to drives and other control equipment, you actually know what you're doing. And so I just think that's very important that that happens. So anyway, let's walk through what happens with a faceplate starter. Okay, so this is showing us what a manual faceplate starter is. And so let me just point out a couple of things to you before we get started. This would be the source of the voltage, the E sub S. And of course, here are two switches that we close. This, these two things would represent fuses that we would have that also could be breakers, right? That would limit, you know, like a dead short that would interrupt the circuit and that sort of thing. So what we have here is, let me show you this part first. This, and I'm not sure, I think this is, you can kind of see this. If we went from L1 to here, then this would be a circuit that is in parallel with the armature. Okay, so this is the shunt field portion of this. Okay, so that's all of that. All right, so what we're going to do is we're going to close this, and we can think about closing it manually. And when we do, and we'll just get a current direction of this way, when we do that, current is going to flow through all these connecting or conducting parts. And so when we first close it, there is 1, 2, 3, 4 resistors that are going to limit the amount of current that can flow when you first close this faceplate starter. Okay, so let's imagine that at first I'm at this point. Okay, and so, you know, just if you thought of different values for this, you know, think about all these resistors being 10 ohms or all of them being 100 ohms, whatever. But initially it would be R1 plus R2 plus R3 plus R4. So you'd have more resistance, less current at startup. All right. So we would do that, and you know, we would have the motor, you know, we'd close it and the motor would start, and you know, the current would be in that range, you know, from 1.5 to 2 that we talked about earlier, 2 times the full load current. And then say, once this machine gets up to a certain speed, let's move this to a different position, and now we'll move it to here. So R1's out of the circuit, and now we're going through 3 resistors. Okay, so now we get a little more current. All right, and then it gets up to say another speed that we select, and we move the contact arm to this point. Now R1 and R2 are out of the circuit, and so now we're just looking at R3 and R4, And then one more time, we move it to here. Now R3 is out of the circuit. Now we're just looking at R4 as being the limiting resistor. Then the last thing that we would do when this motor gets up to the full speed that we want to operate it at, we'll move it to this position. And now it's just taking the resistors out of the circuit. That way we improve the efficiency of the machine because we're not dissipating, energy through these resistors anymore. But at the same time, we've developed a circuit that did that limiting initial current that we needed. Now, think about this. Let's say this is a spring here, okay? And so this is in this position here. Well, we take a turn or two of this shunt field, and it creates this electromagnet here. So as long as current is flowing through this, then this electromagnet is holding the contact arm in place. Now we know from what we talked about earlier with a shunt field, the one thing that we can't stand is a loss of the field, because if we lose the field, then we're going to get in a runaway condition, and we can't allow that to happen. So what would happen, let's say that there was some sort of interruption in this shunt field, then that would de-energize this electromagnet because it's not being supplied current anymore, and the spring would pull this back to the open position. So, it's a manual control, but, it's pretty neat in what it does. It covers all the considerations that we need for this thing to work. Just point out again, here's the excitation current. Here's the voltage that's developed on the armature when it starts to rotate. This is the armature current here. This F is a designated a field connection. And of course, the one thing I want us to get used to is, these L designations, those are the electrical designations for line voltage. Okay, so that's 514.